Hello and welcome to this video on adding rational expressions with a common denominator. This is just several examples where we add two fractions, right, two rational expressions. And these will be some simpler examples where the denominators of each expression are already the same. Both fractions already have a common denominator. So let's begin. So my first example, find the sum of 1 divided by x minus 2 plus 3 divided by x minus 2. And notice, again, I mentioned it in the title of the video, but both fractions have the same denominator or a common denominator. And this is a requirement if you wish to add fractions. Okay. So just a little recap over here of an example of adding some simple fractions with numbers. If I wanted to find the sum, if I wanted to add, say 7/12 plus 11/12, these two fractions have the same denominator of 12, so these can be added. Now when you do add two fractions and the common denominator is present, the resulting sum will have the same denominator. Okay, you do not add 12 plus 12 and make 24. It's twelfths, twelfths, twelfths. What you do add, however, are the numerators. So the resulting sum of 7/12 plus 11/12, you'd have again still twelfths in the denominator, and you take the numerators and add them to make the new numerator. And keep going here. 7 plus 11 is 18. So we have 18 divided by 12, or 18/12 is the sum of 7/12 and 11/12. But we're not done. Okay. As in previous videos, you're always going to be asked to not only add, but this is the sum, but it's not considered totally simplified because the numerator and denominator have a common factor. In fact, the greatest common factor of 18 and 12 is 6, right? If you think about it, 18 is 6 times 3, and then and then 12 is 6 times 2, right? And then you're seeing the common factor of 6 that you can divide out, right? Those become 1. So it's like having 1 times 3 divided by 1 times 2. So 3 over 2 is the final result of this addition. Right, so we're going to want to do that as well. Completely simplify our sums. Make sure that the numerator and denominator of our sum don't have any common factors other than 1. And in general, the addition of fractions with a common denominator will look like this. So if I have a fraction a over c, and I add to that another fraction b over c, or b divided by c, and they have, again, the same denominator, we can put these together. You can add these. And the resulting fraction, the resulting sum, will be over c as well. Right? So the denominator does not change when you add. And the same thing goes for subtraction. The numerator is what is changed as you combine the numerators. The new numerator in the sum is a plus b. All right, and additionally, I'm going to also point out that the value of c, right, cannot be 0. Right? Remember that. I've mentioned that many times in previous videos. Denominators cannot be 0. You cannot divide by 0. So I'm going to keep that in mind as well as we go through adding. Just make sure I'm never plugging in a value that makes me divide by 0. Alright, so in this first example, I have 1 over x minus 2 plus 3 over x minus 2. And I've already pointed out, same denominator here. So we can add these together, and so this will be equal to a new fraction where the denominator does not change, right? Again, they have the same denominator, and when you're adding, that denominator, that common denominator, sticks around as the denominator of the sum. So this will be equal to a fraction with a denominator of x minus 2, and all we're doing really is combining the numerators. Right, so the 1 plus 3. And then we simplify, 1 plus 3 is 4, so the numerator is 4, and the denominator is x minus 2. And then we can ask ourselves, is this simplified? Well, 4 is 2 times 2 when you factor it, and then x minus 2 doesn't factor any further. So there's a factor of 2 and 2 up here, and only a factor of x minus 2 down here. So they don't have any common factors. They don't have any of the same factor. So this is it. And then, as usual, I like to write off to the side, some values I cannot replace the variable with. So remember, denominators can't be 0. So my denominator here is x minus 2. So if I were to plug in a value for x, that value cannot be positive 2. Right? Because if x were positive 2, you'd have 2 minus 2, you'd have 4 divided by 0, and that's no good. All right. But you can check anything else. Right? Test any other value you wish, and I'll do that here in a little tinier writing. Let's test our statement with a value. Now, I can plug in anything other than 2. All right, so plug in 3, 5, a million. I'll do 3. All right, when x is 3, plug it in up here. Right, we're saying that the sum of these two fractions is equal to this fraction. If that's the case, the sum of these two fractions should have the same numerical value as this fraction, no matter what I plug in, as long as it's not 2. Alright, so when I plug in 3 here, that'd be 1 over 3 minus 2. So 1 over 1 plus, and then 3 over 3 minus 2, 3 over 1. Well, that's just 1 plus 3, that's 4. Okay, now let's see the fraction we say it's equal to. When I plug in 3 for x, that'll be 4 over 3 minus 2, 4 over 1, which is indeed also 4. Alright, so we're getting 4 up here. We're also getting 4 when we plug in 3 for x here. So that works out. And again, try x equals 20. Sorry, not 2. Can't use 2. Try x equals 20. Try x equals 10. Try x equals a third. Try x equals negative 5. Whatever. You can plug in anything you wish. And when you plug any value in, the sum of these two fractions should be equal to this fraction here, if they truly are the same. All right, and try it out on your own with some other values if you wish. Again, just not 2. You'll be dividing by 0. Okay. My next example, again, just a couple fractions that we're adding where the denominators are already the same. All right, so these two fractions, you have 2x plus 1 over x plus 1 plus, and then x squared over x plus 1. And again, I'd like to point out, as I have in previous videos, don't just cancel stuff. Like, you can't cancel common terms. You can only cancel common factors. Right? Terms are parts of sums, like you have 2x here plus 1 here, those are two terms. X plus 1, those are two terms. So I can't like cancel the 1's and cancel the x's, and I can't cancel one of these x's here. You can only cancel common factors, parts of products, right? Like back in my original example here with the numbers. When I rewrote 18 and 12 here as multiplication, these are factors, and I see the 6's, I got rid of those. Right? You can cancel common factors, not common terms. There's a big difference. Alright, so I'm seeing here, these indeed have the same denominator, so when I add them together, that denominator will stick around. So I'm going to put this all over x plus 1. Okay, so now this problem's a little different, not much more though, but it's different in the fact that, this numerator has two terms. In the previous example, both numerators were a single term, just 1 and 3. Alright, so what I'm going to do, and it's not super necessary for this example, but I'm going to do it now to get in a good habit of doing it in the future. It'll be very helpful when it comes to subtraction. But I'm going to say, for the new numerator, right, we are going to be adding these numerators. Right? So the first numerator I'm putting in parentheses. This is the first numerator, the quantity 2x plus 1, plus, and then the second numerator. Now the second numerator is only a single term, so there's really no need to have parentheses around it. Right? But the first numerator has multiple terms. And I know you're probably saying, hey, you don't really need parentheses around this either. Again, I'm just getting into the habit of putting parentheses around numerators with more than one term. Now you'd be right though, there is no need for parentheses here because it's not being multiplied. There's nothing I need to distribute, and also there's nothing I'm raising to powers. I'm not raising it to a power or anything like that, an exponent. Alright, so there's the sum, and then we would like to try to simplify it. Alright, so first I like to write all my polynomials in descending order. So up here I'm going to put the x squared term first, and then the positive 2x term, and then the positive 1, right, divided by, and then x plus 1. And then and this is great, this is the sum of these two fractions. It's just not, it might not be simplified. Alright, so here's where the factoring stuff comes in. Alright, so let's simplify. So I'm going to factor, and again I've put up videos on simplifying rational expressions. You want to look for those or find some better ones out there, or read your book. I'm going to factor the numerator and denominator completely. So you have x squared plus 2x plus 1. It's a quadratic trinomial. That would actually factor to x plus 1 squared. You can put to the second power, or you can write them both. X plus 1 times x plus 1, same thing. This is the same thing as x plus 1 squared, divided by, and then the denominator has just the one factor. And again, usually when I'm factoring things and writing out factors, if there's only one factor, I'm going to put a parentheses around it just as a habit, right? Just for style. So this is the only factor down here, right? This doesn't factor any further. So the quantity x plus 1 is the only factor of the denominator. And then before I do any simplification, right? I know you probably already see it, right? They both share a factor of x plus 1. But before I do that, before I simplify, I'm going to point out again values of x that are no good, right? Values of x that I cannot plug in because they'll make me divide by 0. And that would be negative 1. You see in all these, the denominator is x plus 1. So x cannot be equal to negative 1. Right? If I replace x with negative 1, I'll have 0 in a denominator somewhere. Right? You just can't have 0 in a denominator anywhere in the problem. Right? Alright, so as long as x is not -1, we're golden. And we'll go through and simplify. I see that again the common factor of x plus 1 here, so again these both technically become 1s, right? Anything divided by itself is 1. And all I'm left with really is x plus 1 divided by 1, right? Or just x plus 1, right? Because divided by 1 doesn't change anything. So this is equal to x plus 1, again as long as x is not -1. And again, if you want to test that, if you want to test this, plug in a value for x. Is this sum truly equal to this, x plus 1? Well, if this sum is really equal to this here, then you should get the same value for both of these whenever you plug in a value for x, as long as it's not -1, right? Because you'll divide by 0. Alright, so again, if I want to test, say I plug in x equals 2. If I do that here, this will be 5/3, right? 2 times 2 plus 1, and then divided by 2 plus 1, plus, and then here, this would be 4/3, and you see I'm getting, again, same denominator, so the result will be over 3, and the numerator will be 5 plus 4, that's 9, and 9 divided by 3 is 3. And then how about, now I'll go down here, plug in 2. 2 plus 1 is 3. Great. 3 equals 3. Wonderful. And again, you can try anything else. Try x equals 5. Try x equals 100. Try x equals 17, 1/8, and so on. Whatever you want, as long as it's not -1. And this sum should be equal to what you get here. Alright. So I just got a couple more. Again, pretty simple. The denominators are already the same. So here I have 9x over 6x minus 5 plus 2x minus 3 over 6x minus 5. Again, the same denominator already. So we can put them together right now. Make the sum. Alright, so the sum of these two fractions will have the same denominator, right, of 6x minus 5, and that, the numerator of the sum will just be the sum of these numerators. So again, 9x is a single term, right? So I'm not going to put parentheses around it. Plus, right? Plus, and then this other numerator has two terms, so I'm going to put parentheses around it. Right, just to get in that habit when something has multiple terms, putting parentheses around it. So it's the first numerator plus the second numerator. Now again, you don't really need it here. Again, I just like to do it, put the parentheses there, but it's not really necessary because there's nothing to distribute, and also it's not being raised to any powers. So if you didn't write the parentheses here, it wouldn't be technically wrong. And then we keep going, simplifying, combining some like terms. So look at the numerator. I have 9x plus, and then there's a 2x in there, so that's 11x. And then the only other term up there is this, -3. So the numerator is 11x minus 3, and the denominator is 6x minus 5. And then I ask, can this be simplified? Well, the numerator doesn't factor, right? There's no common factor for 11x and -3. So 11x minus 3 is the only factor of the numerator. Same thing for the denominator, 6x minus 5. There's no common factor other than 1. So the only factor of the denominator is the whole thing, the 6x minus 5. So there's nothing canceling here. There's no common factor in the numerator and denominator. So I'm done. And there's one more thing I'm going to point out to myself. Values I cannot replace x with. So again, just only focus on the denominator, right? This 6x minus 5 cannot be 0. So when would that be 0? If you set it equal to 0, you would add 5 divided by 6. So x cannot be 5/6. Right, the fraction 5/6. If you let x be that number, the denominator would be 0. Right, so x cannot be 5/6. So there's the sum of these two fractions. And this fraction plus this fraction will be equal to this fraction as long as x is not 5/6. And again, check it out. Plug in any number you want for x. As long as it's not 5/6, this sum will be equal to this fraction. And you can do that on your own. Plug in 0, plug in 1, plug in 2, 5 billion, -8, -1/3. Again, whatever you want, as long as it's not this 5/6. Wonderful. All right, then I have one last example here, and just a couple fractions where this time, the denominators are the same, but now they're quadratic polynomials. All right, so again, the denominators are the same. So I can add them. All right, I can find the sum of these two fractions right now. So this fraction plus this fraction, the sum will have the denominator of 2x squared minus 7x minus 15, right? The same as the two that you're adding. And it's the numerators that you're adding, right? You only add the numerators once the denominators are the same. So I've got the first numerator. Again, I like to put numerators with multiple terms in parentheses, plus the second numerator, which only has one term. So again, I don't really need parentheses around that. And again, if you didn't put parentheses here, it wouldn't be wrong because there's nothing multiplied by this, nothing distributing over it, and no powers, right? All right, and then we simplify a little more. Let's simplify the numerator. There's this term of 2x. There's no other x's. There's a -2 and a +5. So I make +3 when you add them. So the numerator is 2x plus 3, and the denominator is still this, this common denominator that the two addends had. Okay, so this is the sum of these two fractions. That's all well and good. It's just I would like to, completely simplify if possible. Is there any factor that's common to both the numerator and denominator? All right, so now when I'm factoring, and I'll write factor here. The numerator is simply 2x plus 3. There is no GCF here, right, other than 1. So 2x plus 3, that whole thing is the only factor. And I'm going to put that in parentheses to indicate that, right? The quantity 2x plus 3, that's the only factor of the numerator, right? You can think of it as 2x plus 3, times 1 if you want. All right, and then the denominator, and I've put up videos before of factoring quadratic trinomials in the form ax squared plus bx plus c. You can look at those, read your book on factoring, find some stuff, find some other videos. I'm just going to kind of say this. 2x squared minus 7x minus 15 would factor. We'd have to have 2x in one, x in the other to give me 2x squared. And then I'm looking for factors of -15 to go here and here, so that when I FOIL I get -7x. All right. So that would be I'd have to put -5 here and +3 here, and you can see that when I FOIL, see there's -10x when I do the outers, +3x when I do the inners, and -10x plus 3x would be the -7x that I want, and then you got 3 times -5 is -15. Great. Alright, so I've factored the numerator and denominator completely, and then before I cancel, right, before I simplify, I would like to point out to myself values that I cannot replace x with. Okay, and again, I'm only looking at the denominator. Right? Denominators cannot be 0. So this one has two factors. So if one of these factors is 0, the whole thing would be 0. The whole denominator would be 0, and that's not good. So I've got this factor of 2x plus 3 in the denominator. So when is this equal to 0? Well, if you set it equal to 0, you would have to subtract 3 divided by 2 to get x alone. So that'd be negative 3 halves, or negative 1.5. X cannot be negative 3 halves, because that would make this factor 0, which would in turn make the whole denominator 0. And again, you could also even check back up here. If you plug in negative 3 halves here and here, you'd get 0 in the denominator, right? Because this expression is the same as this product. Not only can x not be negative 3 halves, but it also cannot be 5, right? You have x minus 5 there. If x were 5, you'd have 5 minus 5. You'd have 0 here, which would make the whole denominator 0. And you could also check up here, right? This expression is the same as this product. And if you plug 5 in here and here, you'd get 0 again. Alright, so now that I know what values I can't use, we're going to go through now and simplify, cancel any common factors. I've got a factor of 2x plus 3 in the numerator, 2x plus 3 in the denominator. Now don't forget, when these are dividing out, these are technically becoming 1, right? Anything divided by itself is 1, so just because I crossed off the entire numerator doesn't mean it's gone. Right? There's still a numerator of 1 now. Alright, so when all's said and done, we end up with 1 over, and then x minus 5. Right? The only factor left in the denominator is x minus 5. And since I'm done canceling and whatnot and done factoring, I don't need parentheses around that x minus 5. I mean, you can put them if you want. It wouldn't be incorrect, but it's not really necessary. Alright, and then also I like to, put what's not allowed, right? So this fraction plus this fraction will equal this fraction, as long as x is not negative 3 halves and as long as it's not 5. Alright, so I'll mark that off to myself. And then you can test if you like. Test out with some numbers. Try anything but these two. Right? Plug in any value you wish. I'm going to actually do one real quick here. Let's try x equals 6. Okay. Yeah, if x equals 6, then let's plug it in up here and here and see what we get. Alright, now bear with me here. The first fraction, 2 times 6 is 12, minus 2 is 10, right? So that numerator is 10. And then down here, 6 squared is 36, and then 2 times 36 would be 72, and then minus 7 times 6 is 42. Right, so 72 minus 42, that's 30, and then minus 15 is 15. All right, so that denominator is 15. And then plus, and then let's go to this fraction. Numerator is 5, and then the denominator, we already figured that out, was 15. And now I have 10 fifteenths plus 5 fifteenths, same denominator, right? When I'm adding, I keep that denominator in the sum and add the numerators. 10 plus 5, well, 10 plus 5 is 15, and 15 fifteenths is 1. Alright, so that's what I get when I put 6 in up here and here. Let's see, when I put 6 in down here, I get 1 in the numerator over, and then 6 minus 5 is 1. Well, 1 divided by 1 is 1. I get the same value for both of them, this and this. And again, that should be the case. Try any other number you want, as long as it's not these two, negative 3 halves or 5. Try plugging in 10 or 0 or negative 18 or negative 1/2 or negative 3/5 or pi or square root of 2. Really whatever you want, as long as it's not these two. And this sum should be equal to this fraction here. All right. Okay, and that's all I have for you today. As I like to say at the end of these videos, please, try to get this material on your own first before you go looking for help. I feel like it sticks better when people get it on their own. They feel like they've accomplished more. They remember it better. Read through the material, read through the author's examples, try to understand them. Try practicing problems and checking answers in the backs of books, and but just don't give up after the first attempt. If after the first several attempts at a problem you're still not understanding, it's still not clicking, even try reading through the section again. Read through the material again, maybe 3 times. Be persistent. But if after that, after several read-throughs, several attempts, you're still not clicking, it is not a sign of weakness whatsoever to go out looking for help. Go ask for help. Ask a teacher, a tutor, a friend who knows the material. Go out looking for videos, whether it be this video here on the material or plenty of other videos out there that are better, I promise you. And just keep at it, stay persistent, keep practicing, and I know you'll get it. And try to have fun with it as well. Thank you.